processes related to homeostasis. There are certain processes which are important to regulate or to maintain the homeostatic process in the body. So although they are apparently they are unrelated processes such as biological rhythms and aging, but still we can say that those processes, they have very important implication for homeostasis, and we shall discuss all those in details. The first important process which is related to the homeostasis is acclimatization. Acclimatization, before acclimatization, you should also know the term adaptation. Adaptation is basically those characteristics which favor the survival of any individual in specific environmental condition, that is called adaptation. So it means that adaptation enables the organism to survive in a specific environmental condition. And if you look at the homeostatic control system, they are basically the inherited biological adaptations. They are adaptive processes, and they are inherited biologically. So individuals ability to respond a particular environmental stress, we can't say that is a fixed ability. Different individual, they will show variation in response to certain type of the environmental stimuli. That is not fixed, but we can enhance, or we can decrease the response of any particular individual. So overall genetic endowment will not be changed, but the response of an individual to any specific environmental stimuli, that can be enhanced, that can be altered. And how we can alter that response? By prolonged exposure to that particular stimuli. It means that when we expose any particular organ or any particular individual to an environmental stimuli, initially our organ or that particular individual will show rapid response. But after repeated exposure to that environmental stimuli, the response of the individual can be altered. Although biologically it will be more or less fixed, but that response can be enhanced or it can be decreased. So that's how we can say that the response of any particular organ, particular individual to a specific environmental stimuli, that can be altered by repeated exposure or prolonged exposure to that specific stimuli. So this type of the adaptation, the improved functioning of an already existing homeostatic system, that is called acclimatization. So these are two different terms. One is called adaptation, another is called acclimatization. In case of acclimatization, already present or already existing homeostatic system, that is controlled, or that is improved. The function of that homeostatic system is improved. That is called acclimatization. So okay, let me remove this slide. Slide from previous lecture. Okay. Here we take an example of sweating in response to heat exposure, and all of you must be familiar with this phenomenon, as nowadays it is very common because of the high temperature and high humidity. So if you look at the sweating in response to heat exposure, on day one, let's suppose we expose a person for 30 minutes to high temperature, and ask her or him to do a standardized exercise test as well. So body temperature, when the individual will start exercise and the body temperature is also high and the time of exposure is 30 minutes, so the body temperature will rise, and sweating will start after a certain period of time. And this sweating is actually a homeostatic response to increase the heat loss from the body. The heat that is being generated by the exercise, that heat will be lost by the sweating mechanism, and ultimately the rise in body temperature will be minimized by the excessive sweating from the body in a hot environment. This is one environmental stimuli, and additionally the person is also performing an exercise. So in those two environmental stimuli, our homeostatic response will be excessive sweating from the body to minimize the increase in body temperature, and heat will be lost from the body. So volume of the sweat that is produced under these conditions, that is measured. So for a week or subject that enters the heat chamber for 1 or 2 hours per day and exercise. This was started for 30 minutes, and this exercise and this whole experiment was continued for a week, in which our subject regularly enters the heat chamber for 1 hour, 2 hours per day and exercise. On day 8, the body temperature and sweating rate are again measured during the same exercise test, which was performed on day 1. So the striking difference, or the important point, is that the subject begin to sweat earlier and much more profusely than he did on day 1. So it means now after repeated exposure, our body has adapted, and body will start sweating very rapidly, and sweat will also produce in a large volume as compared to the day 1. So it means this sweating was already present in body. It was already existing homeostatic mechanism in body, but due to the acclimatization to the environmental stimuli, this already existing homeostatic mechanism that has now improved its functioning, and now our sweat gland will start sweating very early, soon after the exposure to the heat, and after the start of the exercise, as well as the volume of the sweat will produced, that is high, larger as compared to the sweat produced on the day 1. So it means and similarly, the body temperature will not rise nearly to the same degree. It means our subject has acclimatized to the heat, and she has undergone an adaptive change. And that adaptive change, or that acclimatization, has been induced by the body, induced in the body by repeated exposure to the heat. And now our body is, or the body of our subject is better able to respond to the heat exposure. So this is what we can call it as acclimatization. So what are the physical or the physiological and anatomical changes that bring or that improved over already existing homeostatic function? Uh, these anatomical and physiological changes, they are also variable, and when we look at these changes, they involve the increase in the number, size, or sensitivity of different one or more types of the cells which are involved in the homeostatic control system. So by increasing the number, either number or the size or the sensitivity of the cells which are involved in homeostatic control system, our body acclimatized to any specific environmental stimuli. So acclimatization, most of the time they are reversible. So if daily exposure to the heat are discontinued, the sweating rate of our subject will revert. It will go back to the pre-acclimatized condition within a relatively short volume. So it means most of the acclimatization processes, they are completely reversible. I mean, they can go back to the pre-acclimatization stage. But if the acclimatization is induced very early during the developmental stages, that is a critical period for the development of a structure or for a development of a response, in that particular case, it will be called as developmental acclimatization, and it may be irreversible. So it means normally most of the time acclimatization processes, they are reversible. But if the acclimatization occurs during the early stages of the development, or during the critical period of the development, then those acclimatization processes, they are irreversible, and those are called developmental acclimatization. For example, if you look at the barrel shaped chest of natives of the Indus Mountain. They are basically not representing a genetic difference uh, between them and their lowland competitors, but rather that is an irreversible acclimatization induced during the first few years of their lives by their exposure to the low oxygen environment of high altitude. Uh, because those people which are living at high altitude, they will face the
Sir,
oxygen deficiency. Yes, please.
sir, sides में फोन नंबर वाली है visible.
कितने नंबर वाली?
फोन नंबर वाली.
अभी मैं 7 पे पहुंच गया हूँ तो आप अभी बोल रहे हैं, बाकी सबको भी नहीं नजर आ रही?
अभी
अब
सर
हमारे
7.
Okay,
Yes sir, अभी 7.
okay. We are talking about the acclimatization, and one example is from the natives of Indus Mountains. Those peoples which are living at high altitude, they will have barrel-shaped chest. Why they will have this specific type of the chest? Because of the oxygen deficiency at the high altitudes. But when we compare those natives of the Indus Mountain with their lowland companions, they will have the broad chest. So these barrel-shaped chest individual, if even they are moved to the lowland areas, still they will have the barrel-shaped chest, because that is basically the developmental acclimatization. Their chest has developed during their development. Their chest has acclimatized according to the environmental condition, and barrel-shaped chest will that is an adaptive change, or that is acclimatization of the body to minimize the oxygen demand of the body at the high altitude. As all of you know, that at high altitude there is deficiency of the oxygen. So this altered chest size, it remains even though the individual move to the lowland environment later in their life, and even they stay there for longer period of this time, still their chest will be barrel shape. It means that is a developmental acclimatization. So lowland persons who have suffered oxygen deprivation from heart or lung disease, they can also have the same chest type, even though they are living at the lowland, but due to the oxygen deficiency because of any heart or lung disease, they can also have their barrel shape chest. So this is one important process which is related to the homeostasis, that is called uh, acclimatization. The second important process which is related to the acclimatization, that is biological rhythm. So if we look at our body is undergoing certain changes rhythmically. Rhythmically mean those processes which are repeated at after regular interval. Those are called rhythmical changes. And if those changes they are taking place, they are occurring in a living individual, those will be called as biological rhythm. So we have a variety of the rhythmical processes which are active, which are operative in our body. The most common type is circadian rhythm. In case of circadian rhythm, as all of you know, that this cycle approximately it is repeated after every 24 hours. For example, we have wake and sleep cycle. This is one of the circadian rhythm. Similarly, body temperature, hormone concentration in the blood, and excretion of the iron into the urine, and many other function. They are basically the circadian variation. Other cycle, they can have much longer periods. For example, in case of human female, the menstrual cycle, it is repeated after 28 days. Biological rhythm, what is their linked with the homeostasis? Uh, Biological rhythm, they basically add an anticipatory mechanism or anticipatory component to the homeostatic control system in a feed forward system which is operating without detectors. So if you look at the negative feedback homeostatic response, we already have discussed this. That is basically the corrective response, and in which the response they are initiated after the steady state of the individual has been uh, disturbed, or what we can say there is alteration in the steady state of the individual. So if you look at the biological rhythm basically will enable the homeostatic mechanism to be active immediately and automatically by activating them at the times when a change has not actually occurred, but the change is likely to occur. uh, Mean it helps the body uh, in anticipation of the any change in the body. Mean our body will detect earlier or before the change has actually occurred in the body. So this is the function of the biological rhythm. That biological rhythm will basically enables our homeostatic system to detect, to anticipate any type of the change that is going to occur in the body before it has actually before it actually occurs in the body. So this is the function of the biological rhythm in our body. So for example, if we look at a rhythmical process in the urinary excretion of potassium, and excretion is high during the day and it is low during the night. So it means because we ingest potassium in our food during the day, not at night when we are in a sleeping phase. So that's why the potassium concentration will be high during the day as compared to the night. So total amount of the potassium in the body fluctuates less than if the rhythm did not exist. So it means if there is no rhythm, then there must not be greater fluctuation in the body. But because of the wake and sleep cycle rhythm, during the sleep definitely we are not eating anything, so that's why potassium level will be lower in the body. So here is a graph or a circadian time hours, and there is you can see the urinary this is urinary potassium plasma cortisol or plasma growth temperature. Uh, these are the various values. So if you look at the circadian rhythm of several physiological variable uh, in human subject, when with room lights on, uh, similarly for 16 hours, and when room lights are off. So these are various what we can say that different time was. Mean when the room lights are on, and they are uh, after 16 hours, and off, which are represented by black bars. So here you can see that these are the black bars. Black bars are actually showing when the lights are off. Okay. So if you look, rhythm is basically, or when we talk about the circadian rhythm, in case of circadian rhythm, we have 24-hour clock or 24-hour cycle, and in which both 0 and 24 that designate midnight, and 12 designate noon. So cortisol basically, here you can see that this 0 and 24, they are basically designate the midnight, and 12 that will designate the noon. And cortisol is basically hormone. uh, the concentration of the cortisol, plasma cortisol, here you can see this is the concentration of the plasma cortisol during this time when there is lights are off, and similarly this time when there is noon, and this time when there is midnight. So this is these peaks are representing the plasma cortisol level in microgram per 100 ml. Similarly, we have plasma growth hormone, and if we look at the uh, plasma growth hormone, here you can see that this is the concentration of plasma uh, growth hormone. Then we have the temperature. This is temperature. Similarly, we have urinary potassium. So here you can see that during the night when the lights are off, this is representing the midnight, and this whole area is representing the night. So here you can see that plasma potassium level is very low during the night as compared to during this daytime. So that's how due to this circadian rhythm, the potassium level fluctuates in the body, and it is high during the daytime and low during the night time. Another important point regarding the body rhythm is sometimes the rhythms, they are also internally driven processes in the body. Mean they are environmental factors. They don't drive the rhythm, but it environmental factors will rather provide the timing cues, and their timing cues are very much important for entrainment. Entrainment means setting of the actual hours of the rhythm. फॉर एग्जांपल हम एक एग्जांपल से इसको समझते हैं या एक्सपेरिमेंट से एक क्लासिकल एक्सपेरिमेंट इन दिस केस subjects, they were put in experimental chamber, and this chamber was completely isolated from their external environment. For the first few days they were exposed to a 24-hour rest activity cycle in which the room lights were turned on and off at the same time each day. Under these conditions, it means that their sleep wake cycles are 24 hours long. It means they are having same environmental cues. I mean, their lights of the chamber that are switch off and switch on at the same time. So all environmental time cues, they were eliminated, and the individuals were allowed to control the lights themselves. This is the second phase. In the first phase, for the first few days, they were exposed to 24-hour rest activity cycle, and in which the room lights were turned on and off at the same time. It means they were not allowed to switch on and switch off the lights on their own, but there was a fixed time, and fixed at that specific time, the room lights, they were either switch off or switch on. In the second phase, environmental cues were eliminated. It means the individuals now they are allowed to control the lights themselves. So immediately their sleep wake pattern begins to change. On the average, bedtime begin about 30 minutes later each day, and so did wake up time. ठीक है, ये बड़ी कॉमन सी एग्जांपल है कि आप अपनी रूटीन को आपको एक फिक्स टाइम दे दी जाएगा, आपने इस टाइम पे सोना है, उसमें आपके पास कोई ऑप्शन ना हो, यू विल हैव ए फिक्स्ड बायोलॉजिकल रिदम. ठीक है, यानी आपने लेट्स सपोज 10 बजे आपने लाइट्स को ऑफ करनी है, सुबह 6 बजे या 7 बजे आपने ऑन करनी है, तो उसमें आपके पास अगर चॉइस नहीं होगी तो आपका जो बायोलॉजिकल रिदम होगा वो फिक्स होगा. बट इन द नेक्स्ट फेज, इफ यू आर अलाउड टू स्विच ऑफ एंड स्विच ऑन द लाइट्स at your own and you have the choice, so your circadian rhythm or your rhythm will shifts slightly, and there may be change in the rhythm. Thus the sleep wake cycle persisted in the complete absence of the environmental cues. This is called free running rhythm. In this case, this is called free running rhythm, and in this case it was approximately 25 hours rather than the 24. It means that cues are required to entrain a circadian rhythm to 24 hours. I mean, if we want to fix a rhythm to 24 hours, we will have to fix the cues in this case is the lights, room lights. If we fix those the timing of the switching off and switching on of the room lights, then our biological rhythm will be fixed to the 24 hours. But if the free running rhythm, in case of free running rhythm, there are no cues that are fixed, that are in trend. So in that specific case, your biological rhythm, it may be shifted to 25 hours. There is slight variation. Another important point is that when the duration of the light dark cycle or sleep wake cycle altered, it can be in trend between 23 to 27 hours, but shorter or longer duration that can't be entrained in the body. So rhythm continue to free run. Because of this, mostly those people who work their body adopt sleep wake cycle longer than 27 hours, they are basically they are unable to achieve the stable rhythms. So it means they will have certain types of the symptoms which are similar to a specific disease that is called jet lag. Jet lag is a specific type of the sleep disorder which can occur in the body due to the disturbance of the biological rhythm. इसका मतलब ये है कि those people which those workers which work more than 27 hours, they can have the jet lag in their body. They can have the symptoms of the jet lag. So light tired cycle is very much important environmental time cue in our lives. But this is not the only one cues. There are certain other cues. For example, external environmental temperature, this is another important factor. Similarly, meal timing is another factor. Many social cues. So all these they are important in regulating our the wake sleep cycle or our light dark cycle. So if several people they are they are undergoing the experiment which we have discussed in previous slide, and those are in isolation from each other, their free runs would be somewhat different. We have discussed that all of them they were put in a same chamber. What if several individuals they are isolated in different chambers and they are allowed to switch off and switch on their lights on their own? Then their rhythm or their free running rhythm would be very much different from each other. But if they are all in the same room, then social cues would entrain all of them to the सेम रिदम. ठीक है, आप बाज़ औक़ात रूम में अपने रूममेट्स की वजह से क्या करते हैं, लाइट्स को आप ऑफ कर देते हैं, लेकिन अगर आप अकेले हों तो आप हो सकता है कि उसको या पहले ऑफ कर दें या बाद में ऑफ कर दें. सो इट मीन्स दिस इज सोशल क्यूज. सो दीज आर सर्टेन टाइप्स ऑफ द क्यूज विच आर इम्पॉर्टेंट in maintaining the circadian rhythm in our body. So environmental time cues also function to phase shift rhythm. Phase shift rhythm mean reset the internal clock, that is called phase shift rhythm. For example, uh, if one just west or east to a different time zone, ठीक है, आप यहाँ से किसी किसी दूसरे मुल्क में चले जाते हैं तो डेफिनेटली आपका टाइम जोन क्या हो जाएगा, चेंज हो जाएगा. तो अब आपका जो स्लीप वेक साइकिल है, बाकी जो सर्केडियन जो rhythmical processes in the body, they will also shift to according to the new time zone. This is called phase shift. So this shift एकदम नहीं होती, ये जो है वो टाइम लेगी. एंड डिस्पैरिटी बिटवीन द एक्सटर्नल टाइम एंड इंटरनल टाइम इज वन ऑफ द कॉज ऑफ द सिम्पटम ऑफ द जेट लैग. ठीक है, जिसमें मैंने आपको बताया कि इफ देयर इज डिस्ट्रप्शन ऑफ द स्लीप, देन वी हैव द गैस्ट्रोइंटेस्टाइनल डिस्टर्बेंस, we will have the decreased vigilance and attention span, and similarly the person will feel the general feeling of malaise. So all these are symptoms of the jet lag, and these symptoms they appear in the body as a result of the disturbance of the sleep wake cycle. Similarly, symptoms of the jet lag can also appear in the worker which are working permanently or on the rotation base. They are working in night shifts. Such individual they will not adapt to these schedules even after several years, because they are exposed to the usual outdoor light dark cycle, which is normal indoor light is too dim to function as a good entrainer. ठीक है, आप जो है वो अगर रात को जागते रहें, आप उसके मुकाबले में पूरा दिन भी सोते रहेंगे, तो आप जो है उस तरह से आपकी नींद पूरी नहीं होगी. वजह ये होगी कि आपका जो एक नेचुरल जो डार्क है, आप बेशक रूम को जो है वो उसमें स्विच ऑफ कर दें, बट स्टिल आपकी जो यूजुअल जो आउटडोर जो लाइट है, जो नेचुरल लाइट है, उसकी वजह से आपका जो स्लीपिंग साइकिल है वो जो है वो कम्प्लीटली फिक्स नहीं होगा. ठीक है, इवन दोज पीपल जो नाइट शिफ्ट में काम करते हैं वो भी दिन को उस तरह से जो है वो प्रॉपरली सो नहीं सकते. ठीक है, this is another slide from previous lecture. So if we talk about the night shift workers, and they were exposed to they are exposed to extremely bright indoor light while they are working an 8 hour of total darkness during the day when they slept. So it means that their total adaptation, this schedule produce total adaptation to the night shift worker within 5 days। यानी आप उसमें ये करें कि रात को आप उनको जो है वो ब्राइट जो है वो इंडोर लाइट प्रोवाइड करें, ठीक है, जब वो काम कर रहे हैं, और दिन के वक्त आप 8 घंटे के लिए उनको टोटल डार्कनेस यानी बिल्कुल जो है वो डार्कनेस आप प्रोवाइड करेंगे, तो फिर तकरीबन 1 हफ्ते बाद उनकी बॉडी जो है या 5 दिन के बाद उनकी बॉडी जो है वो अडाप्ट करेगी, ठीक है ना। तो इसमें अगर हम देखें इसका न्यूरल मैकेनिज्म क्या है, तो इसमें जो हमारा जो ब्रेन है, in the brain a specific part is present that is called hypothalamus. Hypothalamus is a specific collection of the nerve cells which is having the suprachiasmatic nucleus, and this is pacemaker. And as all of you know that pacemaker is very much important. It is time clock and it is important for the circadian rhythm. How it keeps time independent of any external environmental cues, this is not well understood, but we can say that it probably involved the rhythmical turning on and off of the critical genes in the pacemaker cell, ठीक है। अगरचे जो है वो यानी ये किस तरह से जो है वो एक्सटर्नल एनवायरनमेंट से इंडिपेंडेंटली जो है वो टाइम को क्या करता है, फिक्स करता है। इसके लिए जो मैकेनिज्म है दैट इज नॉट प्रॉपरली अंडरस्टूड, बट स्टिल वी कैन से दैट देयर आर सर्टेन टाइप्स ऑफ द जीन्स which are turned on and turned off in these pacemaker cells, and they help in the body in adaptation to certain environmental cues. So such genes, one of them has been named as clock, and the proteins that they code, they have been discovered in mouse pacemakers, and those are actually present in the cells of the suprachiasmatic nucleus. So pacemaker, which is present in the hypothalamic region of our brain, it will receive the input from the eyes and many other parts of the nervous system, and these inputs it will mediate the entrainment effects that are exerted by the external environment. So pacemaker will send out the neural signal to other parts of the brain, and ultimately various body system will be affected or will be innervated by this neural signals, and some of them they will be activated and some other they may be inhibited. So one output of the pacemaker is the pineal gland. Pineal gland is present in the as an offshoot of the brain, and it secretes a hormone that is called melatonin. One is melanin, another is called melatonin. Melanin is a different hormone which control the skin color in the body, whereas if you look at the melatonin is produced by the pineal gland, and neural signals from the pacemaker, they will cause the pineal to secrete the melatonin during the darkness, and during the daylight this melatonin is not secreted. So it is assumed that melatonin may act as an important middleman to influence other organs directly or by altering the activity of the parts of the brain that control these organs. So melatonin secretion is very much important in controlling the activity of the parts of the brain which are involved in control of those organs. So if you look at the administration of melatonin at specific time, whether it can cause the symptom of jet lag, still it is inconclusive, or it is not properly understood, but we can say that any other treatment for jet lag, we can also assume for any other treatment for the jet lag that melatonin or any other specific type of the treatment, if it is helpful in reducing the symptoms of the jet lag, it is yet to be understood. So rhythms, they have the effects on the body resistance to the various stresses and response to the different drugs. Similarly, certain disease, they can also have the characteristic rhythms. For example, if you look at the heart attacks are mostly common in first hours after waking. And if you look at the asthma mostly flares at the night. आपने देखा होगा जो दमे के अस्थमा के मरीज होते हैं उनको mostly रात में प्रॉब्लम होती है. And similarly, most of the people, they suffer from the heart attack, and this is twice more common in the first hours after waking. And similarly, asthma shows the rhythmical activity, and it is more common during the night time. So if we look at the once a day, if we take the pills for the asthma release, if they are taken at night, and if we use the pills for asthma and those are taken at night, and similarly uh, high dose of the medication between midnight and 6 a.m. These are for the heart attack and the disease for the pills for the asthma. If they are used during the night time, they can release the severity of the disease. They can decrease the severity of the disease. So this is all about the biological processes. These are two processes. In upcoming lecture, we shall discuss some additional processes which are also having their important role in the process of homeostasis. Okay, जी clear है? Any question? If you have any question, you can ask. कोई क्वेश्चन नहीं?
सर असाइनमेंट उसमें वर्ड की फाइल में हम भेज सकते हैं या उसमें पीपीटी में?
नहीं, पीपीटी में तो आप प्रेजेंट करेंगे ना, आप वर्ड की फाइल में भेज दें, उसके बाद जैसे ये हम लेक्चर तैयार करते हैं आप ऐसे उसको पीपीटी में कन्वर्ट करें और ऐसे प्रेजेंट करेंगे, ठीक है? और आपका जो क्विज है वो सैटरडे को होगा, सैटरडे को आपका
ओके
क्विज होगा, ठीक है?
ओके सर, ये परसों जो सैटरडे आने वाला है उसको?
हाँ जी।
सर आपने 26 लिखा हुआ वहाँ पे।
26 जुलाई वो तो नहीं
26 जुलाई सर, मैंने 26 देखा था।
नहीं नहीं, वो वैसे आपने क्या देखा होगा, आपका क्विज जो है ना वो उसको हफ्ते को होगा।
सर रिटर्न में ले रहे हैं?
यही टीम पे अपलोड होगा, ऑब्जेक्टिव फॉर्म में होगा, आपने विद इन 10 मिनट्स में करके उसको दोबारा रिटर्न करना है।
ओके सर 10 मिनट्स ढूंढने में गुजर जाएंगे तो
मिल जाएगा, जहाँ पे आपकी असाइनमेंट से आप क्लिक करेंगे वहाँ पे क्विज आ जाएगा, तो उसको आपने जस्ट क्या करना है, उसको सॉल्व करना है। ओके जी, नो क्वेश्चन, प्लीज स्टे कनेक्टेड so that I could upload your